All right, you shall. We'll edit this in post.
Sort of even it out. I feel like it's going to be slanted a little bit.
All right, you're good.
It's rolling?
Yeah.
All right. So first, we're going to write down the givens. Well, the stuff like partial derivatives and everything we figured out, and the formulas we figured out. So u of r equals u of x times x of r plus u of y times y of r. Then we have u of theta equals u of x times x of theta plus u of y times y of theta. And then we have u of r equals u of xr times xr plus u of x times xrr plus u of u of yr times y of r plus u of y times y of rr, and we have u theta theta equals u of x theta times x theta plus u of x times x of theta theta plus u of y theta times y of theta plus u of y times y of theta theta. And then we have u of xr equals u of xx times x of r plus u of xy times y of r. And then we have ux theta equals u of xx times x of theta plus u of xy equals y of theta. And then we have u of yr plus u equals u of yy times y of r plus u of yx times x of r. And then u of y theta equals u of y times y theta plus u of yx times x of theta. Okay, so we have the formulas. Now we're going to put in some of the values that we equated from the partial derivatives. So x of r equals cosine theta, x of theta equals negative r sine theta, y of r equals sine theta, y of theta equals r cosine theta. Then we have x of r equals 0, x of theta theta equals negative r cosine theta. And then we have y r also equals 0, and then y theta theta equals negative r sine theta. All right, so now that we have all our givens down, we can get started on actually solving the Laplacian in polar coordinates. So first, what we're given for the first step is u of r plus 1 over r times u of r 1 over r squared times u of theta theta equals u of xx plus plus u of y. So the first substitution we're going to make is we're going to substitute u of rr in one of these formulas in for here. So we'll make a little note over here, sub u rr. So we're going to get u of xr times xr plus u of x times xrr plus u of yr times y of r plus u of y times y of rr. And we're going to bring these two down because we haven't substituted for them yet. So 1 over r times u of r plus 1 over r squared plus u double theta. And then for our next step, we're going to sub in just u of r, so this term, and bring this down here, plus 1 over r times, we get u of x times x of r plus u of y times y of r, and then we can bring this down too, so it's going to be plus 1 over r squared plus u of theta theta. And then for the fourth step, we're going to sub for u of theta theta. So we can bring this down here and this down here because we've already substituted for those. And then we're going to go plus 1 over r squared, plus sign shouldn't be that, and then we're going to go times u of x theta times x theta plus u of x times x theta theta plus u of y theta, times y of theta plus u of y times y of theta theta, and that's all we need to do right there. So we're going to go down to the fifth step, and we're going to sub uxr and uyr. So here uxr, so let's see, we have uxr here, so we're going to go with uxx times x of r plus uxy times y of r, and then keep that its own term, times x of r plus u of x times x of rr, and then we have our next, we have u of yr here, so we're going to substitute u of y times y of r plus u of yx times x of r, and then multiply that by y of r, and then bring down the plus uy times yrr, and then let's see, there's nothing left in either of these that is UXR or UYR, so we can bring both of these down. So it's going to be plus 1 over R times UXXR plus UYYR plus 1 over R squared times UX theta times X theta plus UX times X theta theta plus UY theta times Y theta plus UY times Y theta theta. We don't need to write all that down. So we can come down to the 6th step. By the way, there are 15 steps. I went step by step so we don't really get mixed up with anything that we're plugging in. So the 6th step is we're going to sub UX theta and UY theta. So in this term, we have nothing that's UX theta or UY theta, so we're going to bring this down. This stays the same. And then we're going to go, we'll move over here so we don't get confused. But we're going to bring that down as well because there's no UX theta or UY theta. And then this term is the one we're focused on this step. So we're going to go plus 1 over R squared times. We're going to keep everything separate for now. So we're going to go with, actually I should probably change one of those. Change something to bracket. So we're going to go bracket, parentheses, bracket. And then, so we're substituting for UX theta, which is U of X times X theta plus U of X Y times Y theta. And then this parenthesis, and then times X theta. Actually, no, that should be the bracket. Times X theta. And then we are going to go with, let's see, we're going to go with plus UX, this stays constant, X theta, theta, plus, and then here's our other term, our UY theta. So we're going to go with bracket, actually we should probably go parentheses, bracket, U, Y, Y. Remember, we're substituting here. So this is one of the givens. UYY times Y theta. And then plus UXY times X theta. And then close the bracket. Times Y theta. And then plus UY times Y theta theta. Close bracket. So this is the term we focused on this step. So now I'm going to erase all of this. This is, we just finished step 6. So I'll read out the entire formula that we should have right now. For the first term, U of XX times XR plus U of XY times YR, that times XR plus U of X times XRR plus UYY times YR plus UYX times XR and that term times YR plus U of Y times YRR plus 1 over R times UXXR plus UYYR end term, and then plus 1 over R squared times UXX times X theta plus UXY times Y theta, that whole term by X theta, new term plus UX times X theta theta plus new term UYY Y theta plus UXY X theta, that entire term by Y theta plus UY times Y theta theta. So I'm going to go ahead and erase all this so we can move into our next step, which will be plugging in XR, YR, X theta, and Y theta. So we can get rid of all this. Okay, so for step 7, we're going to substitute x of r, y of r, x of theta, and y of theta. So we're going to open bracket, u of x times cosine theta plus u of x y times sine theta, close bracket, times cosine theta plus u of x times x of r plus open bracket u of y times sine theta plus u of xy times cosine theta, close bracket, times sine theta plus u of y times y of r plus 1 over r times u of x times cosine theta plus u of y times sine theta. This should be bracket. So we'll close this bracket and then move on to the third term, which is 1 over r squared times u of xx times negative r sine theta plus u of y, or u should be u of xy times r of cosine theta, close bracket, all times negative r sine theta plus u of x times x of theta plus open bracket u of y times r cosine theta plus u of x y times negative r sine theta, close bracket, times r cosine theta, close this parenthesis, plus u of y times y theta. We can close this bracket, and that's the 7th step. So we can move on to the 8th step, which is just substituting the second derivatives. So x of r times y, and y of r, and x of theta, and then y of theta. So let's see. I don't really want to rewrite this entire thing, so we can just draw arrows down for the ones that we're going to substitute. So this u of xr, or xrr, will turn into 0 and cancel this whole term. This y of rr will also turn into 0, canceling this whole term. This x of theta will turn into negative r cosine theta, and this y of theta theta will turn into negative r sine theta. So that's the 8th step. And we'll move on to the, let's see, move this a little bit. Now for 9, we're going to distribute sine and cosine. And we are going to get u xx times cosine squared theta plus u of xy times sine theta cosine theta plus u of yy times sine squared theta plus u of yx times cosine theta sine theta. Moving on to the next term, so 1 over r times, this looks like it's going to stay the same, so just u of x times cosine theta plus u of y times sine theta, close that, and here's the trickier term, 1 over r squared times u of xx times negative r sine theta squared. Since there are two terms, there's an r and a sine in here. We're going to keep that exponent outside. Plus u of xy times r cosine theta times negative r sine theta plus u of x times negative r cosine theta plus u of y times r cosine theta squared. Again, we're going to keep the exponent outside. Plus u of x y times negative r sine theta times r cosine times r cosine theta plus u of y times negative r sine theta. All right, so that's the 9th step. For the 10th step, we're going to start separating the r's. So this term stay the same, we'll bring that down. And then for the second term, we're going to put it all over r. So u of x times cosine theta plus u of y times sine theta. And we're going to put each one over r. And then for r squared, this one's a good bit tricky here. So we're going to go u of x times negative r sine theta squared over r squared plus u x y times r cosine theta times negative r sine theta over r squared plus u x times negative r cosine theta over r xy times negative r sine theta times r cosine theta, again, over r squared, and our final term, u of y times negative r sine theta over r squared. So, from here, we can move on to the 11th step, where we're going to start finding things that can cancel out. So let's actually bring these down, where we're going to have say u of xx times, it's going to be r squared, since the negative will turn into a positive. So hold on. R sine squared theta, so that'll turn into a negative over r squared. So we can cancel these. We can move this over here, and then we can go plus u xy, and these will get multiplied together, so it'll be negative r squared times cosine theta sine theta over r squared. So that can cancel, that can cancel. We can bring this and turn that into a negative. And then we can go plus u of x times negative r cosine theta over r squared. This, take away the exponent. We can move this, make it minus. And then we can go plus u of y times r cosine theta squared over r squared. So we can erase this, make this cancel, cancel. That'll stay positive. And we can go plus u of xy times negative r sine. That will turn into a negative r squared times sine theta cosine theta over r squared, which we can cancel, turn this into a negative. It still looks like a positive. So we can turn this into a negative, and then for the final term, u of y times negative r sine theta over r squared, canceling r for the exponent, so this is also a minus. And then what I'd like to do is bring down the rest of the terms so that we can start canceling everything. So we'll bring down the u of x times cosine theta over r plus u of y times sine theta over r, and we'll bring down this entire thing. So u xx times cosine squared theta plus u of xy times sine theta cosine theta plus u of yy times sine squared theta plus u of yx times cosine theta sine theta plus. So here we have a negative uxx times sine squared theta. Actually, we're not going to cancel the negative uxx, so we have a negative uxy sine or cosine theta sine theta, so we can cancel that out with the positive uxy sine theta cosine theta. Here we have a positive ux or uyx cosine theta sine theta for a negative, let's let's see. I think I copied this one wrong.
It's right in front of you. It's the u of x, y, it's the same as yx.
Yeah, it's the same as yx, so we can still cancel this out. I accidentally wrote yx, or xy instead of yx, and then we have a negative ux cosine theta over r, which we can cancel with the positive version, and then positive version of this cancels with the negative version of this. So let me erase the top line, and we can move everything up here. So we only have 4 terms left, which are the ones we want. So we have u xx times cosine squared theta plus u y times sine squared theta plus, minus u xx times sine squared theta, and then let's see, minus, where's the last uy? There it is. Actually, there's never a negative here, so this should still stay positive. My mistake. Then we have plus uyy times cosine squared theta. So in order to visualize this better, I'm going to erase everything under it. Okay, so we can pull out u of xx, and then make that a sine squared theta plus cosine squared theta, make plus uyy also times sine squared theta plus cosine squared theta. And then we know our trig identities, so these both equal 1, which is u of xx times 1 is itself, plus u of yy times 1 is still itself, and then that equals what we wanted to find at the beginning, which was u xx plus u y y. Thank you.